Welcome to the video which concerns the puzzle Stay Centered, which is shown here. And the puzzle is as follows. It features two squares, a large one and a small one. They share a vertex, and the small one has the opposite vertex along the side over here. And there is the triangle connecting the common vertex to the other two, a red triangle, and the question is to prove that this point over here, which is halfway between those 2 points, is in fact the circumcenter of this triangle. And I can show, if I do this, you see there is indeed, and I can also vary the size. You see that indeed always that point is the circumcenter of the red triangle. These points are on the circle. So the question is how to prove it. Well, one way is to use perpendicular bisectors of chords. What you know is if two perpendicular bisectors of two chords, they should intersect exactly in this point. Well, if I make visible, let's say all the points, the first is rather obvious. If you take this perpendicular bisector of this line segment, it obviously goes through the point because it is halfway from symmetry. So that's not very hard. What's harder is to show, we will show that the perpendicular bisector of this segment also goes through. I can show it, but I have to prove it, of course. You see, it goes exactly through this point. But how do I prove it? Well, the trick is to see that this angle over here is 45 degrees. This angle is 45 degrees because it is the diagonal of the small square, and it makes an angle of 45 degrees. But that means that it is also that the diagonal of the large square exactly goes through this point. So these 3 points are aligned. And what's more is that this angle over here is a right angle, of course, because of the small square. It's a right angle. But we can then draw the circle, basically the circumcircle. Let's see, if I draw the circle from here, which passes through here, and it also goes through this point because of this right angle, but that's not necessary here. But what you know is that this circle has this as a chord. So this is a semicircle, and because this is a chord, we know that the perpendicular bisector of these 2 points exactly goes through the center, because this is of course the center, you see, because it is halfway the diagonal, the diameter. This point is halfway the diameter because of the right angle. This is a diameter. So we know that this point is the center of this smaller circle, but that means that the perpendicular bisector of this line segment exactly goes through it. Well, now we are in business, because the perpendicular bisector of these 2 points is, of course, because of the square, the same as the perpendicular bisector of these 2 points. So what we have proven is that the perpendicular bisector of these 2 points passes through this point. And because we already had that this one also passes, then it must be the unique intersection point, and therefore it is the circumcenter of the red triangle.